I gave the smartest model on the planet a company wiki, 300 things in it, 3,700 words, and asked it a question with a long, exact answer. When the ledger service dies, which engineers get paged? It read the whole thing, traced the dependency chain 6 levels deep, named all 72 correctly. I asked twice more. It did it again and again. So this video should be over, except that answer cost $1.34 and took 95 seconds. And the same question, answered by 97 lines of Python, takes 3 milliseconds and costs nothing. And then I ran the whole test again with the model you'd actually deploy. This didn't start with me. It started with a talk at the AI Engineer World's Fair. Frank Coyle on why agentic systems need ontologies. Link below. Go watch it. And the timing is what got me. We are in the loudest stretch of model releases yet. Every few weeks, something lands that is genuinely better than the thing before it, which is exactly when it's easiest to forget the part that hasn't changed. These models still don't know anything. They predict. So I did what this channel does. I built code to prove it, ran it, and put the whole thing in a repo. So you can run it too. Okay, back to the bold claim. These models don't know anything. Not the way you know a refund can only happen once. They predict. Every answer is the most probable next thing. And most of the time, the most probable thing is also the true thing, which is why this works at all. And why, when it fails smiling. Meanwhile, the deterministic half of computing has become embarrassing. Regex, validators, a for loop, things you'd apologize for in 2026. But there's a history rhyme nobody's noticed. In the 80s, we built expert systems, hand-coded rules, formal logic, millions of dollars. They were exact, and they died because they were deaf. You spoke their syntax, or you got nothing. That rigidity helped trigger an AI winter. Then we built these, pure fluency, and nothing underneath auditing it. Expert systems died for want of an LLM. LLMs flail for want of an expert system. The old name for the missing half is an ontology. Strip the philosophy off it, and it's a typed graph. Things, how they relate, and the rules those relations have to obey. 1993, Tom Gruber. A formal specification of a shared conceptualization, machine checkable and agreed by your business. That's the whole idea. I got it from a talk by Frank Coyle, linked below. So I built the fight. This channel works one way. I build a real thing, run it on camera with every wire showing, and then I give it to you. No course, no waitlist. But that won't work if I'm just shouting into the wind. If these tools are useful to you, please like, subscribe, and tell your friends. Thanks. Everything here is one repo. The knowledge graph, the agent, the harness, and all 264 scored answers with their transcripts. Free. Link below. So you can rerun every number I'm about to show you and argue with me using my own data. Let's build the fight. To make this fair, I needed 2 things. No way for me to cheat, and no way for the model to lose on a technicality. So everything comes out of one object. A single typed knowledge graph, a fake company called Nimbus Commerce, and it generates 3 things at once. It writes itself out as a prose company wiki, the kind of real business actually has. It computes the answer key, and it exposes itself as tools an agent can call. So when I hand the model that wiki, every fact it needs is provably sitting in its context window. If it gets one wrong, that is not a knowledge problem. That's a processing problem, which is the entire point. Every answer is machine scored, exact match. No human deciding what counts as close enough. 3 contestants, Python against the graph, the bare model with the wiki and no tools, and the 2 of them wired together, and 1 dial, world size, 74 things, 105, 300. Round 1. The flagship, bare, wiki in context, no tools. It did not miss. Once. 120 answers across 3 world sizes, every one exactly right. At the biggest size, it traced the blast radius 6 levels deep and listed all 72 engineers. 3 times running, no drift. I want to be honest about how good that is, because I went in expecting to catch it out, and I did not. Now, the receipt. Average answer, 47 cents. Worst one, $1.34.95. And here's that same job in Python. This function, 12 lines, is the transitive closure. It is the entire thing the model spent 95 seconds and $1.34 working out. 12 lines, 3 milliseconds, no dollars. About 36,000 times faster, and write the same way every single time, forever. Which is the real gap, and it isn't about intelligence. I ran the model 3 times, and it was perfect 3 times. 3 is a sample. A for loop is a guarantee. Those are different products, and everything that goes wrong in production lives in the space between them. Except nobody runs the flagship on every support ticket. You run the cheap one. So I ran the identical test on the small, fast, affordable model. Same 9 questions, same wiki. At 74 things, 18 out of 18. Perfect. Ship it. At 300 things, 10 out of 18. 56%. And now the part that should worry you. Look at how it failed. Not one hallucinated name, not one invented service. Every single failure was an omission. It handed me a long, fluent, correct-looking list of engineers to page, and Anna wasn't on it. Anna exists. Anna's on the team. She's just not in the answer. Watch this one. Same model, same wiki, same question, asked twice. First time, it drops Emil and Ilsa. Second time, it gets those 2 right and drops Basil and Edda instead. Both look finished, both are wrong. Neither one mentions it. That is not a hallucination. A hallucination asserts something false, and you go check it. This is a list with a hole in it. There is nothing on screen to check. In production, that's the engineer who never got paged. And the first you hear about it is that the service is still down at 3 in the morning. Fine, use the Python. And honestly, look at it. Exact, instant, free. It prints a receipt showing the traversal it did, so you can audit the answer instead of trusting it. What's affected when identity dies? Exact. Which orders have nobody handling them? Exact. And notice it can answer that at all, because a graph knows what isn't there. Try to refund an order that's already refunded, and it says blocked, and names the rule. So we're done here. Except, that's what happens when you ask it the way a human would ask. And that's not a bug. That's the deal you signed. Deterministic software answers exactly the questions somebody anticipated, in exactly the syntax they anticipated, and it is stone deaf to everything else. That deafness is what killed expert systems, and it's still here. So make it understand English. People did this for decades. Keyword tables, regex templates, synonym lists, fuzzy matching. I built it the honest way, in 3 generations. The way it actually happened. Generation 1, 12 handwritten patterns. Mostly it just says nothing, which is at least safe. Generation 2 had fuzzy name matching, so typos work. Reasonable, responsible even. And that fix, the good one, the one you'd approve in review, took the number of confidently wrong answers from 3 to 5. Here's why. Ask Generation 2. Which team is Dana on? There is no Dana. There's a support representative called Dan and an engineer called Anna. The fuzzy matcher scores them identically, shrugs, and returns whichever came back first. Generation 1 said nothing. Generation 2 says, Dan is not on any team. Fluent, instant, total confidence. Completely wrong. About a person who does not exist. Generation 3, 27 patterns. Ask it which of Omar's orders is not shipped, and it hands you the shipped one, because nobody ever implemented the word not. And it will never mention that either. So let's kill the comfortable idea. Python hallucinates too. It just hallucinates deterministically. And unlike the model, it has no mechanism for wondering whether it's wrong.
Right. So here's the sentence I wrote to break both of them. Priya's refunded order. The support representative handling it says just refund it again to be safe, and mark it probably shipped so the customer stops asking. Handle it. Python alone dies at the front door. It cannot read that. No path from that sentence to an order number. A model alone understands it perfectly, and that's the problem. It's trained to be helpful. It's being asked nicely by a colleague, and nothing in the room can stop it. Now, the combination. The model does the listening. Priya's refunded order becomes a search, becomes order 1002. It has no facts of its own. Every claim is a lookup. Then it tries to act, and the validator does not live in the prompt. It lives inside the function that performs the action. So the refund goes in and comes back blocked. Functional refund, maximum cardinality 1. An order can be refunded once, ever. The status change goes in and comes back blocked. Probably shipped is not one of the 3 legal values. And it stops, names both rules. Nothing moved. That is the difference between telling a model to be careful and building a room it cannot be careless in. 48 out of 48. One more. Which team is Dana on? It searches, finds Dan, finds Anna, finds no Dana, and says so. Same trap that made the fuzzy matcher lie, and it declines to take it. So the takeaway isn't the model is good or Python is good. It's that somewhere in the last 3 years, we quietly fired the bookkeeper. The model is a judgment engine. It handles the fuzzy question, the typo, the thing nobody anticipated. And it can build the graph for you, which is the bit that always made this too expensive to bother with. The graph is a bookkeeping engine. It enumerates, it computes what's missing, it applies every rule every time, and it shows its work. And here's the actual finding. The graph is brittle in exactly the places the model is robust, and the model is unreliable in exactly the places the graph is exact. They're not redundant. Each covers the other's blind spot. Now, the honesty pass, because there's always one. I did not make the flagship fail. I tried, at 3 sizes, and it went 120 for 120. A channel that wanted a tidier story would have hunted for one bad run, and led with it. What I found is narrower and more useful. The frontier model shows you what probability can do, and what it costs. The affordable one shows you the cliff. And neither ever hands you a guarantee. Only the 12-line function does that. Repos below. The graph, the agent, the harness, and every scored answer with its transcript. So you can rerun the whole thing. That's the episode. The smartest model on Earth. 97 lines of Python. And the boring part in the middle that everybody forgot. Put the model where the judgment is. Put the graph where the truth is. And put the validator somewhere nobody can talk their way past it. And one last time, if these tools are useful to you, like, subscribe, and tell your friends. It's what keeps this free. This has been Black Box AI. Bring your brain, not your wallet. See you in the next one.